Hey everybody, this is Rydo and we are back to Human Resource Machine. Let's hop in. So far so good. We've made it to 20 years and, well, 19 years, and we haven't had to go to our code once over here for the solution. Now I'm noticing something on how this is animated. It's a very, there's a noticeable line here in that this side of the face is bigger than the other. It's like a left brain, right brain divide or something. I don't know if there's an implication there or not. You may also notice that our ID badge, we are balding and look older. Uh, when this character was first started, if we click it in new for a second, she looked like this with the pigtails. I look like this. I guess I'll have to click something here to get back. Um, so that you do after a certain time become older, and of course you become older because you're spending a year to do each one of these programs, which is a decent commentary, I suppose, to how difficult programming can be. Of course, the programs we're getting here, we're not spending a year on. I haven't even gotten to the point where I'm spending an hour on them. Seems like only yesterday that we were learning that about adding. Fond memories. We worked so hard back then. So our new thing is for each two things in the inbox, multiply them and outbox the result. Don't worry about negative numbers. We've got labels. They can now help us remember the purpose of each tile on the floor. So just tap on any tile on the floor to edit. So now I can do things like this. I can write write or draw something. Uh, so if this was going to be the 1,000 tile, I could put 1,000 here, and then I can click copy to the 1,000 tile instead of copy to the 1 tile. So that will help us. And we have hello and 0 already here. Now, if you come back here and delete this, it's gone. Also, if you do something along the lines of drawing something here and then clicking on the tabs, they are gone. So it's independent to each one. Although if you copy and paste, which you often probably might, it's still there. Even though this defined section isn't listed in your list of things, it is still there. And oddly, it's still here even if you click the clear button. So, like, it's a little weird. It's a little bit of a bug in the system. Anyways, tell me more. I hope you enjoy the new label maker. I personally prefer to label just about everything. Copy to for, what does that even mean? Just stick a label on it and you'll never need to use numbers again. I have also labeled my sandwich, so now you know which one not to eat. You're welcome. So, let's get rid of this to start off with. And what we need to do is multiply. So how are we going to multiply? What we can do, multiplication, and you need to understand this at the core of programming. Multiplication is just addition. So 5 times 2 is just 5 plus 5. 5 times 3 is just 5 plus 5 plus 5. 5 times 4 is just 5 plus 5 plus 5 plus 5. That's all multiplication is. Also, division, which we'll get to that in the future puzzle, is just subtraction, but subtraction that refuses to go into a negative number, so it has to be exact subtraction. Otherwise, you're going to go into decimal places, and that's not something we want right now because we're doing integer math here. We aren't using numbers uh, that can go into decimal places. Integers being the same as whole numbers. Only whole numbers is what we're interested in. So we get the first thing, we copy it to 0. We then get the second thing and copy it to 1. And then what we can do is add this to this. So this is going to be result. Now, we don't need it to say hello, that is not informative. Also, we have the beginning of this. We need to copy from 0 to result because we need a 0 there, otherwise it will give us an error. And so we need to do that much. It will be a second jump that gets back to this when we are done with the multiplication. So we've added it once, but before we can even add it once, because what if this was 0? Then we wouldn't add it anytime. So we need to bump down the first number. We can call this first. And notice how it changes everything, and we can call this second. So if the first number is 0, do that. Don't worry about negative numbers. Whenever they say don't worry about negative numbers, that means they're just not going to give you any negative numbers, which means your programming doesn't have to be robust, which means don't bother to make it robust. What's our optimization goal? 15 commands and 109 or fewer steps. And what's an example? If your inbox is 2.3, send out 6. If your inbox is 0.9, send out 0. So I think this works. Let's see if we're missing something. This, and that. No, I didn't do that right at all. I need to copy the second number to second, then bump first, because then it changes what's in my hand, and then copy from second and add it. That gives us 12 commands. Our optimization is 15. I still probably have a mistake here. That seems like being 3 commands short seems like a lot. Yeah, this jump is not in the right place. Here we go. So, when you are doing multiplication, at least when you are programming multiplication in this very basic form, you would want to have the first number be the smallest number possible and the second number be the largest number as possible. True for division too, you'd want the first number to be the smallest number. Oh, you know what? I forgot to outbox the result. If 0, copy from result, and send it out. That puts us at 14 over 1 short of the goal. So that should work. Of course, in any real programming language, you wouldn't do this. you wouldn't do this for two reasons. One, because there's by default in almost every programming language, well, any one I could think of that is legitimate, you would just send, let's see, what did I do wrong there? We put this here, we bump this, we copy from this, and we add it to result, and we get the number, but we have to then copy it back to result. There we go. And that gets us at 15. Any legitimate programming language is going to have multiplication in its commands, so you wouldn't need to do this. This is something that was probably figured out by calculator makers in circuitry decades before personal computers became a big thing. Also, there's a thing in CPUs called the math coprocessor, which has circuitry specifically designed to do multiplication way faster than if you gave it the same commands individually. So you can send to a math coprocessor. It needs one more, so I need to fix this so it just jump if negative instead of jump if 0. That's usually what you need to change if you're one off in your cycles. So yes, you'd send something to the math coprocessor in multiplication. It would send you the result very fast. It may even have in its memory just hard-coded the result, so it doesn't even have to calculate it. If you sent what's a million times a million, it may have a list of what a million times a million is, say it's this, here you go, you're done, and not actually do any processing or calculating at all. And so for those two reasons, this is an illegitimate challenge. It shows an understanding of math. I would almost suggest this game as an educational aid for math more than programming, but either way, it's still kind of not informative enough. So there's no problem in the first number going down to negative, because it just gets overwritten there. Here's a great example of if I just put one extra code to say if either one of these numbers were 0, just output 0. That helps. That would remove a lot of steps here. As we see, it's just adding 0 to 0, adding 0 to 0. We don't need to do that. Much like if a math coprocessor has a multiplication table in its memory, we can just assume, regardless of what the other number is, if one of them is 0, it's going to be 0. Here's the same example, but it works a little bit differently because the first number was 0. As soon as it got bumped down to negative, they just grabbed the 0 that was already there and sent it out. Same could be true for 1. Anything times 1 is that thing. That's a little bit more difficult to calculate for, but certainly doable. But you would never write a program like this. Maybe this would be your 4th or 5th program in a programming class. It's like make a program that multiplies without using the multiplication. No, you wouldn't do that. I couldn't imagine any classroom project where they said do multiplication without using the multiplication command. I could see a project do multiplication if you have the multiplication command with it, use it, but never could I imagine without. So if I just add these two jump if 0 commands to output box 0, that will save us some time. Let's see how much faster that would be in the number of steps. Well, that made a mistake somehow. Let's see. Inbox. A 1. Oh, I see what I did wrong here. If I grab the first inbox and jump if 0, I need to actually inbox a second time and then outbox. And then jump back to the beginning. So that I can actually jump back to this point because I don't need to copy the zeros again. So that should fix that. Of course, there is more optimization we may do here because what did I do wrong this time? We get a 0, we jump if 0. Oh, we need to outbox, then inbox. That's what we need to do. So we may move the numbers around so that the bigger number's in the second place. But if we get the challenge with just those two special circumstances, I don't see a real reason to work on the code anymore. 146. So, yes, let's optimize a little bit better now. So, on the second, right here, we're gonna say if greater than, what we'll do, we'll get that second one and subtract here, and if it's negative, what we'll do is we will then copy to, well, we'll copy from that, but first thing we'll do is we'll copy to 3 as a temporary thing, so temp, and then we will copy from first and move it to second, and then we will copy from temp and move it to 1, and if it's positive we will simply do that. Now we just added quite a lot of commands there, and I copy to temp, copy from first to second, copy from temp to first. There we go. We've added 1, 2, 3, 4, 5 commands. So you're asking yourself, how in the world can those 5 commands here act as any way as useful to help? So also we need to add another command here to add it back because we don't want to lose our number. And then we also need to jump from this point to this point. So we're adding a lot of commands. How can this possibly be faster? Let's watch. I'll be really embarrassed if this isn't faster. So we put the 4 down. then we subtract this and we get a negative number. So that tells us the 3 is the smaller number. And we did it wrong. We forgot to get the number back, so we need to add to the first and try that again. Again, good to understand this concept, not really useful in the real world. So 3 is smaller than 4. That's what we want, the smaller number in the first. That way we add the bigger number, and that will reduce the number of loops. So we've got that 12. Now there's more optimization we could do. We could say when the first number hits 0, just add number 2 to results one last time in outbox, instead of going back and jumping to the first, bumping it down to a negative number, testing if it's a negative number, and then getting the results. That certainly could be more optimization. Will it be necessary? Maybe, maybe not. So you saw there in that loop, it moved the command, it moved the numbers around. Here in this code, we'll have the most optimization possible. We'll just say 0, so we're done. We'll say that's 0, so it's done. Now, in this case, it needs to toss the 2 because it doesn't matter. And here we have 2 minus 9, which is good. So instead of adding 2 9 times, we only add 9 2 times, which is the same result. Multiplication is a grid, so one way or the other way will always be the same for real numbers, at least. So that's 31 commands over double, and that gets me down to 134 steps. So more optimization needed, as we thought. So subtract if 0 on this case, instead of it being not that subtraction, that's not the subtraction we need. Here we have bump the first. If it's 0, instead of it just copying the result, it's going to copy from this and add it to this, and then outbox it. More commands. We're adding more and more commands to make it more and more efficient somehow. Let's see this jump here. If 0, outbox jump, that's right. If so let's try this and see how many steps that takes. Should have been 12. What did I miss here? If 0, I need to copy from second and then add result and then outbox. So for each input, one extra step is multiplied. That's the real multiplication you should be afraid of, is one extra step, one extra command not necessary gets multiplied for every input. If you send a program a million inputs, your program is a million times slower. So now we're down to 119. That probably means that we get 10 inputs and there's simply one step we don't need in this. So let's get rid of the label. Here, get rid of that. jump if 0 necessary, copy to first, inbox subtract, if it's negative add it back, and then jump to this point, which this jump forward tells me I could copy all of this stuff and remove that jump forward and just unroll that loop. So copy to 2, copy to second, bump minus first, jump if 0. They also start all loops like this, which is not good for something like this because this would just be an infinite loop. If you left one of these in here and ever reached line 15, there'd be no way that program would ever execute. Copy from second, add result. Let's see, copy from second, add result. Copy to result. Same code, just using it again, and jump back to this point. And let's see. Copy from second, add result again, outbox, jump to the beginning. Where are we? Where are we? This is the jump of 0. Copy from second, add result one more time, outbox, and jump to the beginning. So now we're up to 43 commands. 43 commands just so the program runs faster. 10 steps faster. And certainly I'd love to see programmers make their programs run faster, but it didn't save me any steps at all. Wow. So what's something more I can do to optimize here? Inbox, if it's 0, skips a lot. Copy it to 1. Inbox, if it's 0, skips a lot. Subtract that one. If it's negative, go here. Move. Copy it to temp, then copy the first one to the second one. And you know what we could do? Instead of doing these commands to move things around, what if instead we did something sneaky and just copied this to both of them? And then if it's negative, copy to the let's see, if it's negative, let's see, add the first and then copy from first attempt, copy to first. Let's get rid of that, that, and that. Otherwise, copy to second. which I don't think this jump needs to be here. I think I should have taken that one out already. Which means this jump doesn't need to be here. So this is the problem with optimizing your code or just programming in general, is you'll start to have bits of code that are not labeled at all and you just don't know what they're doing here. So we're getting tricky here. We're going to put the 8 in first and second. Then we're going to subtract the 2 from the 8. If it's negative, we're going to put it in the first. If it was positive, we would have put it in the second, then begun the math. So that saves us a couple efforts, a couple steps as far as what we need to do. So we put the 2 here, we get the 3, it's positive, so then that means that goes in the second space, and then we go to the addition, or multiplication broken down into addition. There's, as far as I can tell, no way to actually do just instant result multiplication here. I couldn't see anything that would allow for that. And we never get a multiplication button or option. It's just not in existence. We've come into a problem here. What we need to step back. We hit a negative number and it didn't end the command. It should have ended the command when we hit 0. So this was what, 1 times 3? No. So we inbox a 2, and we put the 2 here and the 2 there. We get a 3. We find out the 3 is bigger. We add it to get the 3 back and we put it there. That's right. And then we bump this down. We should get 6. We add that, that's 3. We bump it down. And at this jump, we should... This jump actually needs to be going to line 31, where we copy from second, add second to result one last time, then outbox. Let's try that. Keep it nice and speedy if we can. Will this save us that 10 steps? Hopefully. I'm kind of out of ideas off the top of my head. You certainly could spend months or years thinking about your programs, thinking of ways to speed them up. See, I'm still 6 steps short. Where are those 6 steps coming from? Let's see, we have a jump here, we have a jump here, we have a jump here. And going, if you jump here, you're not taking a step to go to here. Your next step is here. We need 0 as the result. And it wouldn't save time if we overwrote the 0 here. That would actually add steps. In some cases, overwriting the 0 makes sense because you have something else in the code later that is going to return it to 0. But in this case, not really. And remember, this code would not really work if we had negative numbers at all. Copy to 2, bump. Copy from second, add to result, and copy to result. Copy from second here. If it's... Would I ever use this code here? No, nothing jumps into this code, so this is actually redundant, I think. See, this here, copy from second, add result outbox, is the same as this, copy from second, add result outbox. Jump that far. And then add this, and then copy to 1. Which I guess I don't need to do that, do I? I don't need to add it and copy it to 1 because it's... this triggers... Well, I think I do actually. Bump this, if 0, do this. Perhaps if we move things down in this fashion and then change this to jump if negative, just as an experiment. We'll try this. Perhaps this is adding a step here. Let's see. If we jump if 0 here, that's something we have to have. And then outbox versus this outbox, that would be no different. And then it goes back here, that would add a couple steps. That would make it slower. Expected 4, but you outbox 12. So we get to this, we take this, we add this, we copy it to that, we bump this down. It should be at 0 right now. So the jump if negative was wrong. It should be jump at 0. Maybe I have added a ridiculous amount of extra code here. Maybe I've added far too much code versus what I really needed. I think I may have. You can certainly make programs that are in this fashion where you think you're doing right by them and really there's a much easier way. Yeah, I added these extra copy from seconds and add to results are unnecessary. So here and here, completely unnecessary. After I moved the code around a little bit. Wait. jump of 0 still needs to copy from results, however. So slightly, one of those was unnecessary. The other one was. Okay. Try that again. I like the buzz, the bump when you make a mistake. It's not super annoying, but it does catch your attention. You could certainly have put the wrong audio cue there and severely irritated people. Wow. 121. My lowest has been 115. I added 6 more steps somehow. How did I add 6 more steps? How did I add 6 more steps? Interesting. Jump of 0, copy from result, outbox. This one is just outbox and jump. This one's outbox and inbox and jump. This one jumps to that point. It would be so easy too if you could just hold something, 2 things in your hands. If the bump just incremented things downward and you didn't also get a copy in your hands, you would still have the result before in your hand and you'd save so many steps. So this way of doing things is odd. You get here after this point. So what if instead we copied to first here, and that way we don't have to add or that right there. But subtract to first, and if it's negative, copy it to first, otherwise copy it to second. No, I don't think that's right. Subtract it. If it's negative, add it back, put it in first. If it's positive, add it back, put it in second. And then from that point, we could save a step by doing this, adding it to the result, copying it to result, checking, bumping first. If it's 0, skipping out, otherwise copying from second, and going back to add to result. So maybe that one change? No, because on this case, then everything's backwards. You'd still need to copy from second. Jump of copy from result here and outbox. And this jumps here and outbox is, so what does this jump to? Just if it's 0, outbox it. So let's try it. Let's see if we've improved enough. We've hit that point though. We've hit that point where the program is taking an entire hour to do if you want to do everything. 1:19. So now is where my preparation comes into handiness. We click back here and we go back to my game that I've already done everything on. And we just need to click on, let's see, where are we? Multiplication workshop, I believe. Year 20. And we have a 1, 2, and 3 optimized. So let's play 1 and see what result that gets us. This was probably the first program I did that succeeded. Notice nothing's labeled here because I have a tendency not to label things. Also, I think I kind of breezed through this. So 22 commands, 121 things. So that was probably how I beat it the first time. Here I added R total for running total to it, and you can see it's 15 commands, which our optimization goal is 15 commands. So I did that one, and we can quickly run through it and see that with my goal in mind of just shorter code, I was able to do it. So this time I bumped, and then if negative, I copied from our total and outboxed, which probably saved us a command somewhere. No special circumstances at all. And notice though that that's 178 commands. So let's now look at 3. 3 is 32 around here. And let's see what happens. It seems like I just move it manually back and forth. Subtracts the number, adds the number, and then puts it in a temp place, and then copies it from a temp place to put it there. Adds that to that. Oh, you know what I don't do here? Is I don't bother to copy the 0 at the beginning. Instead, I just copy from this and to that. And that must be how I'm saving the steps. I'm not doing anything super complicated. When I reach this, I bump and then jump of 0 first, then I copy from 1, and then R total, add to R total, and then do that. Bump, add that, add that. That's all I do. So I was going too complicated, which is often the problem here. Unfortunately, there's not a great way to compare this code to the other code I was working on. I certainly have already written this code. This is something I wrote myself, so in a different mindset a couple of days ago I wrote this code and got it to work, but now being a little bit more burned out, being in a different time frame, in an hour or 40 minutes of working on it, I couldn't quite recreate it. I was very, very close. There's not a ton of difference here, and I certainly went with the temp swap concept at first and thought that was not a savings worth using, but obviously it was a savings worth using. I forgot, however, and didn't get the concept of not using the 0. So that's 109. So if we back out to our save file that we're recording, and we can probably adjust it, hopefully. So this is where it really goes to show doing the game once before helps a lot. So we just don't need to copy from 0 to result at all. We just don't. Instead, let's just see if it works. We've got an 8, we put here. We've got a 2, we put here. We take this, and when we copy something to second, we need to also copy to result. And we also need to go ahead and get rid of this jump if negative stuff. So instead of unrolling that, we'll just, let's see, go with this. Jump if negative, copy to temp, copy from first, copy to second, and when we copy to second, copy to result also, and then copy from temp to copy to first, and then when all that's said and done, go back this way to that. This copy from result in this outbox reduces the need of this to nothing, and that should work. Let's see. 7, 7. Subtract. Put it there. Put it there. I did something wrong there. Let's see. I think what I did is I didn't add it back. It should be 2. So add that. Two. When we subtract this, it's positive, so it goes there, goes there. That one should solve fine and give us 8. Right? Well, not quite. It was supposed to be 8 and it doubled up on us in some odd way. What if I just copied to temp also? If we subtract the first number and then we copied to the result. That's good. Otherwise, if it's negative, copy. Do I really need to copy the temp and then temp the first, or can I just copy the first and get rid of all the rest of it? Yeah, I can get rid of all the rest of it. That eliminates quite a few steps right there. But there's still something, I think, missing as far as this. Maybe that'll fix it. Hopefully. 5, 5. So we have a 4 that we want the 4 there. So we just stick it there because we already put the 5 there. And then we need to, I think, add this command back into it. And let's see if that works. That's 2 extra commands, but I think it's necessary and not going to be a problem. No, that was looking for 12, but I think I can fix that just by moving that around. Will that work? So this is going to be It's funny, I just saw the solution. I just saw the solution, and I'm still having some problems with it. I could also jump if 0. No, that wouldn't work. So this should be 9. It is 9. Good. This should be 6. Good. This should be 0. And it wasn't. Why? Why did the 0 fail? Because I've lost the jump of 0 command here. Somehow. Jump if 0 to outbox and then back to the beginning. $32, but expecting. This is where programming starts to go. So we have 4 here. That's right. Then we add the result of 4 to it. No. So I've hit the point in programming where I just want to see the errors. If it works, I don't care. Give me the errors only. And I didn't have any errors that time, which is good. Of course, the question now is it good enough? No, it's not. So, at an hour, the right thing to do is simply use knowledge from other places. And that's really where this game doesn't get into a level of what programming also is about. It's about borrowing, using, understanding, yes, but also sometimes just not understanding other people's code. So here I just have to copy my code from before, and that's what I want to do, and paste it into the second tab and run it. This is also an admittance that I can't guarantee that I will show you how I came about naturally the creation of the code or anything to get all of the achievements. Some of them I cheated straight up. I copied code from online sources, walkthroughs, solutions, typed in the puzzle name, typed in the Google and solution and got it. Which it's not really a matter of I wouldn't ever have been able to solve it. It's just I'm a video game critic on YouTube. I have a lot of games to cover and I can only put so much time into the game, and I've already put quite a significant amount of time in this game playing it once already. But we can try and look at this. Inbox, and then it jumps of 0 to this point where it outboxes and inboxes and jumps. We had that code. Then it copies it to 0, which was first. We could certainly even mark it first if that helps. It copies it to first, and then it inbox is the second number. Again, if it jumps of 0 to this point where it will outbox and then jump right back to the beginning. Notice there's no copying from 0 to our total. Then it subtracts the second number from the first. If it's negative, it adds it back. Then it copies it to 4, which we can just call temp. I should have labeled. And then it copies from this to this, which we can call second. And then it copies from this to this. And then it copies this from this, the second number. Next thing it does is it adds it to the running total. And then it bumps down first, as usual. It copies from this and adds it to this. So the program always assumes that it's going to do at least a multiplication of 1, which it can do because of the 0, and that's what's saving it to steps. So it bumps it down first, checks if it's a 0. If it is a 0, it would go to this point, get a running total, and outbox it, and then jump back to the beginning. If it's not a 0, it then copies the second number and adds again, and then copies it to running total, then jumps back. It's almost exactly the same code as what we have over here. Almost exactly. These are different. This isn't included. When it switches around, it does it in a different fashion. Let's see. But that's pretty much all that was different. It's just a few little discrepancies. We have 3 things jumping to the top here, where only 2 are here. And I could certainly go through the code back and forth and try and figure it out, but it's not worth it. So that's going to be multiplication workshop. This is when the puzzles start getting difficult. Don't be surprised if going through here we end every episode doing just one puzzle and showing you the solution. Fibonacci Visitor and these three in particular are really difficult. I'd never even got one of the challenges on that. Anywho, that's going to be it for this recording. As always, I ask you to like, share, subscribe. Sorry, I've been talking so long. Comment if you want to, and watch every second of my videos. If you want to support me, you can click on my name, Rydo. On the right will be a blue button that says support this channel. Click it, make a donation. And if you want to friend or follow me on basically any social media sites, there's a whole bunch of links down below. Thank you for watching. Have a good evening.